Okay, hello everyone. I'm very happy to have Anil Kumar Pradhan as our next speaker for Crypto Cafe. So Anil Kumar Pradhan is a cryptographer specializing in practical privacy enhancing technologies and their deployment in real world systems. At Vaultree, he works at the intersection of advanced cryptography and industry adoption, focusing on fully homomorphic encryption, encrypted machine learning, and secure computation at scale. With a background spanning both academic research and enterprise engineering, he bridges the gap between theoretical innovation and operation feasibility. Anil has contributed to projects that bring cutting edge cryptographic methods into production environments with particular attention to performance optimization, compliance, and developer experience. He is passionate about making strong cryptography usable, scalable, and impactful across industries that handle sensitive data. Anil Kumar Pradhan is the founding cryptographer and cryptography research lead at Vaultree, Ireland, and has over a decade of experience in applied cryptography. He holds an MSc in mathematics from IIT Delhi and a BSc honors in mathematics and computing from Institute of Mathematics and Applications in Bhubaneswar. Over to you, Anil. You can share your slides.
Thank you, Dipan, for the kind introduction. I don't think I need to introduce myself anymore. Uh, but just a quick summary. Like I have I understand most of you are from academic background, and but my background is slightly different. Like I work mostly on the industry side. Uh, so like I might not have the same kind of understanding of the concepts that you have, but I will try to um, present in a such a way that should be useful to you. So, yeah, let me know if you can see the screen.
We can see the slides.
Thank you. Uh, yeah, so I'll be focusing more on few ideas today, like from industry perspective, how people see FHE or why it is relevant to them, and based on that, like you will see what are the real applications that people are looking for in industry, and then what are the core challenges. Like it's pretty obvious the few things, but and then the potential solutions that can be used adapted to address the core challenges. So I'll start with how the current state of data privacy is in the most of the industry or most of the companies are following at the moment. So they try to do the data they try to be very serious about the data privacy, but most of the time when the data is transit or in rest, the data is encrypted, and it is widely kind of common understanding that encryption is the best practice to keep protect the privacy of the data. So they try to encrypt it at every step, but they can at the moment they can only encrypt when the data is at rest or in transit. But whenever they want to use the data, they have to decrypt it. The use can be like any context, like for example in machine learning case, either it can be training or inference, or there might be there might be other situation. I will explain some of them through the coming yeah, use cases. So what brings why people are so passionate about FHE is that we can solve this gap uh, which can uh, enable the organization to use the data while it is being encrypted. So if they want to perform certain like machine learning or any other kind of analytics, they still can do that without decrypting it, and hence like this will be the data will be like protected throughout the like all stages, um whether it is like at rest or transit or in use. So this is the promise kind of FHE gives, for which people in the industry are more interested in adopting FHE. So like you probably already know the like basics of FHE. Like if you like you can encrypt the data and then send it to a server which to whom you don't trust, and yet still you can perform like computations on those data without decrypting them. So from industry perspective, what it does is it unlocks various use cases. Like for example, one of them is machine learning use cases. Well, like it's still like a work in progress. Obviously, it is not done. But the idea is if like we can do the full like unleash the full potential of FHE, then we can potentially like perform uh, machine learning models on the encrypted data. Like it can be inference in the beginning, maybe like hopefully like they can do training as well in the future. Um, that would be the most impactful use case or applications in the industry if that can be done. Another use case can be like private set intersection. Sometimes, like many organization, they want to work, they want to collaborate on various things. Like they want to check if, like if organization A have a particular customers, or organization B, they both have any common customers. This is kind of like applications of private set intersection where they can figure out this without disclosing any of their customer data. And right now they cannot do it because of the regulation. They cannot like organization A cannot disclose any information about their customer with organization B, and they are kind of blocked with this kind of applications. And another use case can be like private information retrieval. Uh, this is like a interesting one. Like this came to us recently. Like right now, few messaging app, they want to like protect the privacy of their customers. Like for example, if you are using WhatsApp, for example, the customer has to share all their contact information to WhatsApp, so that WhatsApp can say which of these contacts are already in WhatsApp, and you can message them. So to enable this kind of solution, you have to like disclose the like your all of your contact list to the server. Otherwise, they cannot provide the service. But here there are few like messaging app who are serious about the data security. They want to like solve this problem uh, without letting the user disclose all its contact list. So like here like maybe private information retrieval or PIR can be a potential solution for this kind of situation, where like the users won't have to like disclose the contacts in the plain text. Instead, they can encrypt their contact, and then the server can check which of the contact is matching like already is a existing customer, and then they can enable the user to like start messaging with them. uh, so these are the many some of the use cases which are uh, people still want to like want some solution. By the way, for this kind of solution, some companies are using like trusted execution environment. Like they send encrypt the whole data and send it to a TE, and they perform like most of the computation there and get the result out. But they are the people who are more serious about the like data privacy and security. They are like they wants to like use like FHE kind of solution, any kind of cryptographic solution instead of like hardware security solutions, or maybe both. So these are the some of the problems. Like if FHE gets to its full potential, and this kind of problem are solved can be solved. And yeah, these are the main reason why most of the people in the industry are interested like about FHE, and they really wants some sort of solution in this domain. Uh, yeah, so like we can divide the like most of the applications, like the machine learning and deep learning can be the like most more complex or challenging to solve like using FHE, and on the other side, PIR, PSI, or like predictive learning can be like slightly simpler. But yet I think it's like it depends, but on the scenario. But we can like for simplicity we can classify on those types. Uh, the obvious there are obviously like they are not still able to adapt properly. There are few challenges, and the obvious one is of course the storage. Um, I'll come to performance, but like for storage, like if we take an example, like right now, if like we encrypt plain text which is almost 16 bits, we can obviously use the batching as well. But like roughly, like we estimate, if we estimate the storage over it, like if we take the 16-bit plain text and we encrypt it, the ciphertext modulus has to be like approximately like 256 bits or maybe more, depending on the use case and the number of operations you want. uh, but this is a rough calculations. But if we take this scenario and take these assumptions and calculate the overhead ratio, the plain text which is plain text to ciphertext ratio is will be like around 32, which is like at least 32, like it can be more as well. But from the industry perspective, like if you say like if an organization, like most of the big organization, they have a like huge amount of data, and they are spending millions of dollars to like keep those data, for example in AWS or like any other cloud system. If we just directly go to them like hey and ask them to use FSA, and if they, even if they do, they have to like kind of pay at least 30 times more on the storage over it. If they are using like they have a huge amount of data, like and they are using some expensive cloud server, they have to like pay at least 30 times. Like for example, like if one big company, they are like spending 1 million for data storage, they have to now pay like 30 million. So these kind of like challenges comes when like we approach the like big companies who wants to use the FSG, although they want the solutions, like they want the like advanced functionality like machine learning or private set intersection, those kind of functionality, but they won't be interested like if you know, like if you say like you have to now pay 30 times more on the like data storage. So this kind of scenario comes when like solving the problem in the like industry side. And of course like the performance is they're like they have to check whether like this is worth worth the investment. um then one of the like potential solutions like we saw recently is the like it can be like uh transciphering, which is basically like you can encrypt the data using AES. Again, like I don't have the like exact theoretical understanding how it works, but if you on drop, since it is like if you have the plain text, you can use like some symmetric cipher to encrypt the data and store it. So symmetric cipher is not that expensive, like the data size won't grow that much. So you can like definitely encrypt them and store it at the same level, similar cost. And then you can encrypt the key using FHE. And then using homomorphic operations, you can convert the AES encrypted data to FHE encrypted data. So these can be potential solution for like the storage problem. Like for example, here, like if when they like in the beginning they had to like pay kind of 30 times more on the storage cost. But now they can pay similar thing, but it would increase increase the computational cost, given that the transciphering it might not be like um as simple as regular operations like addition and multiplication. It can be costly there. So like again the so it would be like again questionable like whether the cost for transciphering is worth like having that. Again, so, some of the academic people are also researching on this domain. So this hopefully if we get some efficient transfer ciphering, this can be a potential solution, which can reduce the cost of the storage back to normal. So like people might be interested in using this kind of solutions. Uh, and one more thing is on performance side, obviously the bootstrapping itself, like if you are doing multiplication on the encrypted data, obviously it is few milliseconds, or not few, like some milliseconds. But if you are doing like bootstrapping, like more than 10 or 20 multiplication, then you have to apply the bootstrapping, which is a few seconds. So overall, the cost of multiplication or like individual operation being will be bring will cost us like more than seconds. So that is also like not that won't be an acceptable solution in practical scenario. Like for example, like if you are performing some machine learning inference, it usually take few seconds in plain text. But if you do it, if the bootstrapping itself would cost uh, seconds, then like it can like go up very quickly. So these are the like storage and performance are the kind of major challenges when it comes to like adopting FHA. And then there is some specific challenges for like machine learning. uh, One is like one of the most expensive cost is the activation function which are used in machine learning, and there is no direct solution. But like yeah, there can be like a polynomial approximation, but like if you want very accurate result, the degree of the polynomial has to be like slightly more. And then it would also like it would bring us back to the bootstrapping thing. Like after a certain point you have to apply a series of bootstrapping, and that will like also increase the cost of overall inference timing. And one more thing, like I have not written here, is the matrix vector multiplications, and that is also like one expensive part of the like machine learning or deep learning. If you are using deep learning on the encrypted data, you have to do like matrix vector multiplications, or even matrix to matrix multiplication sometime. But this is also like one of the expensive operations which might need bootstrapping. uh, so these are the like few challenges while adopting efficiency in the industry, uh, and hopefully like the transciphering and other few techniques can help overcome this. But we are like working mostly on like how to address this kind of problems. um yeah, there is one more potential solution is if you can use GPUs uh, on like if you can use run the like whole operations on this GPU, because remember like most of the like uh, costly operations would happen on the server side, and it is reasonable to expect that a server can use GPU. But if it was in the client side, obviously there is no options for GPU like or any specialized hardware to use, because the client side would be like usually a normal MacBook or mobile cell phone. But because like most of the computation would happen on the server side, it would be like a reasonable solution to use specialized hardware or GPUs or any sort of on that side. So like there are few experiments done by some people like we came across, and they have like reduced when they like run the bootstrapping algorithm, for example. If you run it on CPU, it might be several seconds, but if you run the same algorithm on the GPU, it can go down few milliseconds. So these can be a potential solutions for addressing the performance part of the problem. So like overall the core problem storage and performance. Storage can like potentially can be solved like hopefully using transciphering, and but it will bring us few performance challenge on the way. And like the performance part hopefully can be solved using like maybe like advanced algorithms like which will be like embedded in future. But like it has to be like combination of some like a existing algorithm as well as some specialized hardware. So this these two combination can potentially like solve majority of the problem which is like still present right now. And like most of the people in industry, they still wants this kind the solutions, but they don't want to spend a lot of like 30 times or more on this kind of solutions. So yeah, this is potentially the hopefully the bring us the solution in the future. And yeah, so that's all I have. I have kept it short, but like from industry perspective, this is all information I have. So if you have any questions.
I have a few questions. So when you say FHE, do you have any concrete FHE in mind? Because we know there are different types of FHE available from different industries. For example, Microsoft has HELib, Crypto Lab has something called CKKS. Like for instance, in the industry, what kind of homomorphic encryption, concrete homomorphic encryptions do you use?
It depends. There is not one kind of FHE that can solve most of the problem.
Yes.
But if it depends purely on the applications, like for example, like any machine learning related applications, CKKs might be a good choice, given the like it supports the floating point or the complex numbers, and the approximate bootstrapping. Um, and has been like few developments on like algorithm sites as well. But the it, it depends on the application. Like on other side, like for example, like there are few other applications where like most of the data can be integers. uh, like like for example, the example I said about the contact, like private information retrieval, like in messaging apps. If The server wants to know what are the your contacts and who are your existing customers. Uh, then CKKs might not be like a good choice because we don't need the floating point numbers, and CKKs, the ciphertext modulus can be used given the scaling parameters and everything. So for that, there might be other options like BFP or like BGB, um, but it also depends on whether we need the bootstrapping or not. So like if it is purely integer data and you never need the floating point, maybe you might not need the CKKs as well. So it is purely depend on the like applications. So whether it's your data is like floating numbers or integers, or like how many operations you need based on that.
Okay, like I have one more question. So with FHE, like you cannot have the control on what to decrypt, right? Like decryption is possible for everyone. Have you had this thing like some advanced FHE where you can have control like which data set to be decrypted and which not? Like for example, like some kind of thing called functional homomorphic encryption. I remember I read it at some point of time. Do you think it's practical? I don't know if there is anything implemented in practice, but is there anything like some advanced FHE schemes? Is something people in the industry are looking for this kind of things?
Mm, they are definitely looking for this kind of things, but like we have not came across any like proper solutions for this. Like for example, like uh, few use cases where you have to like do comparisons on the like, oh, when you compute the data, like once you have done the computations, like you have to compare the data, and based on the comparison results, like whether the results is small or large, you have to do different kind of computations. Like in this scenario, like it would be more suitable if you can decrypt the result and see whether they are and based on that you will take the next step. But unfortunately, like with the existing FSC, like this might not be possible. Like even if you do comparison, then also the comparison result will be like, for example, if you do comparison of x and y, if x less than y, whether x is less than y, even if you do encrypted comparison, the result would be encrypted. Like
Of course.
then, like you don't know then what to do, like or like how which step to follow. So in this, like this is like still challenging, and I think this is still an open problem.
Okay. Okay. Any questions from the audience? Yes, we have a couple of questions. Yes, Francesco, you can start.
Go ahead. Okay. So you were mentioning CPUs and GPUs for implementation. Are you also considering TPUs?
uh I am not aware of that, like we have not thought about that, but like maybe that can be interesting. Do you have any interesting result on that domain? Because
No,
for
I just that this is something that I've heard about a bit, and I was wondering if you companies are already looking at other architectures.
Yeah, we might look into it, but right now we looked into GPU, and they are giving pretty good result. But like, this is something we might look into in future as well.
Okay, thank you.
Thanks for like giving that question.
Yes, Hansraj, you can ask.
So in one of the slides, you mentioned the potential solution, trans-ciphering, and that is like AES, you use AES. So will that solution will be like post-quantumly secure?
Uh, I well, it partially depends on the key exchange, of course. But I'm not sure. Like if there is like a quantum algorithm to break symmetric ciphers like AES or not.
No, but you just increase the size of the key in AES and then it's still secure. I mean, Gruber's
So
algorithm.
for AES, we don't have like quantum algorithm.
Gruber's algorithm can solve like the quantum search a little bit quicker than the classical, but the solution in AES, so it's claimed still to be secure also in post-quantum era. If you just double the key size.
I
So
see.
it's like 2 to the power lambda versus 2 to the power square root of lambda.
Yeah.
That's the
Okay.
thing.
Yeah.
So you can just double it and then it will be like lambda with secure again.
Yeah.
It's well known, like
Yes,
you
yes.
have this such thing which is very fast using this Simon's algorithm things.
Mhm.
So
Okay, thank you.
Yeah. Thank you.
any questions? Okay, so I think that is it. If there is no question, let's thank Anil for his nice talk on FHE for the industries. So
All right. Thank you, guys.
let's keep in touch. So thank you again for your talk. So hope to see you sometime soon.
Yeah, absolutely. Thank you so much.